For this unit, Chapter 5, we have been focusing on different ways of finding the zeros for a quadratic as well as for finding the vertex for a quadratic. And in the next couple of questions that we are doing today, we are looking at how we can apply this information to help us solve problems. So in example 1, what I have here is a picture. So the picture would be like right here. So let me draw some things in here. So here's our little sunshine in the picture, and then here's Mrs. Logan. She's out playing with her puppy dog. There's the puppy dog with his waggedy tail. And then this picture frame measures 30 centimeters by 45 centimeters. So the frame itself would be 45 centimeters wide, perhaps, and then it would be 30 centimeters long, or you could call that the width, and then the 45 the length. It doesn't really matter. And then this thing, it's called a mat. The mat is the, it's kind of like the paper part that goes, oops, didn't mean to color into there, but you can see I've drawn the picture within the inner rectangle. The mat is this spot, this section here, which is like a frame or a border. It's sometimes a different color. But it helps to frame the picture. So the actual outside edge is the frame, but then you've got this inner edge here. So it's often a solid color. Sometimes it has a nice gold highlight around it or whatever, but that's what the mat is. And it has a uniform width, so the distance between the frame and the actual picture is the same. It's uniform all the way around it. So all of this is the same width. And I could let like X be the width of that mat. So the mat with a uniform width is placed inside the frame to surround the picture. If the area of the mat should equal the area of the picture, what width should the mat be to 1 decimal place? So I'm going to let, and I don't know why I put 30W. I think I was talking about width. I just noticed something here. I'm going to put 30 centimeters there, not 30W, 30 centimeters there. We could let our variable like W or X be the width of the mat, because that is what we are being asked to find. What width should the mat be? So you should have a let statement there to indicate what your variable is going to be. I'm going to let W be the width. Actually, I'm going to just let X as and W would be the actual width of my picture. Let X be the width of the mat. Okay, so we're using a let statement there, and I'm good with that. Let X be the width of the mat. And the area of the mat should equal the area of the picture. So that would mean, like, if I took the whole area is length times width. If I were to take this 30 and multiply it by the 45, that would give me the area of the mat and the picture put together. So I could do area equals length times width, and my total area, so the total area for my picture would be 45 times my 30. And if I grab my calculator, 90 plus 45, I think that is 135 there. I don't have my calculator in front of me. I think that area is 135 centimeters squared. I should go grab my calculator. If that is the case, what we need to do is take that and cut it in half, because the mat's area would equal a half of that, and the picture's area would be a half of that. I'm going to run and get my calculator. I'm putting this on pause. You can think about coming up with a strategy to be able to calculate or solve this problem. Okay, so I went and grabbed my calculator and realized I just did 3 times 45 instead of 30 times 45, so it just adds a 0 on my numbers there, and that makes more sense then. All right, we need to come up with what the width should be. Now, I know that the total area is the 1350. The area of the picture then should be half of that, and the mat should be half of that. So I'm just going to put a picture, area of picture. It would equal that 1350 cut in half divided by 2. Because the mat has to equal the area of the picture, and together they have to add up to be the 1350. So that means the area of my picture should be 675 centimeters squared. Now I also know if this entire length or width, whatever you want to call it here, is 30, and if I'm letting X be this width of the mat, then my picture's width or length, whatever you want to call it, would be 30 units, but we're going to take away an X and an X. We've got to take away this piece of X and this X, which the width then of my picture would be 30 minus 2 X's. Okay, now see if you can come up with an expression for the length being from here to here, the length of the actual picture. See if you can come up with an expression for that, what that distance is from here to here. Okay, if you've thought about that, the whole length across, or the whole thing across, is 45 units, centimeters, but we're going to bring it back by x units on either side, so this should be 45, take away 2 x's. So my area of my picture really is given by a length times width, so this area of the picture would also equal, area of the picture would also equal length times width, which would be the 45 minus 2x times the 30 minus 2x. So now I really have an equation here that we need to solve. We know that the area of the picture is also equal to 675. So my 675, whoops, wrong button. My 675 would go here. The area of my picture is 675, but it's also equal to length times width. What I need to do is solve for the x that's going to make my area equal 675. I need to solve this equation for x. Okay, so I'm going to let you try and work through that, and I'm going to do a solution up, which I will post later, or you can ask me for the solution. I do want to talk about business applications briefly here. I'm going to slide over slide. When we talk about business things, we have 3 terms here that we talk about a lot. One is revenue, and revenue is the amount of money that you make from selling items or providing a service. So my example that I use is let's say you have a lawn cutting business. Okay, your business is cutting lawns. And let's say for an in-town lawn, you're charging $25 each time you cut the lawn. Your money, your revenue, the money that you make for cutting the lawn would be $25 every time you cut the lawn. So it would be 25 times the number of times you cut the lawn. Your costs, so your revenue is not actually your profit. Your revenue is just the money you're bringing in. But you would have costs. For example, you might need to make sure you have good shoes. So you'd have the cost of your shoes. You've got to run the lawnmower, so you're going to have gas that you have to pay for, and you might want to, take your lawnmower in to get serviced, like an oil change, or get the blades sharpened. So you've got costs associated with running your business. So out of the money that you make, that $25 for every lawn, you've got to set aside a certain amount to cover your costs for actually providing that service. The money you have left over, that's what we call the profit. So your profit really is, your profit, capital P, is equal to your revenue. Take the money you make, but subtract your costs from that. So with cost, we use a capital letter C. With revenue, we're using a capital letter R. Profit, we use a capital letter P for those. So hopefully that makes sense for you in terms of that. Let's say instead you are making, are providing, like a company is making, let's say, oil filters for cars. The money, their revenue is the money they generate from selling the oil filters, but they're going to have a whole bunch of costs. They've got employees that they have to pay, they've got hydro they've got to pay, they've got to pay for materials to actually make the product. Their profit would be the money they bring in from selling their oil filters, but then they subtract all the costs that accumulate for actually producing that product. All right, so we're going to apply that to our next example here. Dharma sells an average of 30 necklaces per week at the beach for $6. So each necklace she's selling for $6. It costs her $1.50 for materials to make each necklace. So you can see this is talking about like revenue here. It's what she's selling each one for. It's costing her $1.50, so that's talking about the cost function there. She's done a survey and found that for every 50-cent increase in price, she's going to lose 2 sales per week. So instead of selling 30 necklaces per week, if she increased the price to $6.50 each, she would now only sell 28 necklaces. We're going to use quadratics to help us determine what price she should charge to maximize her profit. Okay, so in order to do that, we need to have some variables here. Now, I know our revenue. Our revenue would be the number, oops, wrong. I've got a little text box now. I don't know how to get rid of it. Oh well, I'll work around that. Our revenue, the amount of money that Dharma makes, would be given by the number of necklaces she sells and then we take that and multiply it by the price they're sold for. So if she's selling 30 necklaces for $6, her revenue would be 30 times 6. If she increases her price to $6.50, her revenue would be 28 times $6.50. If she increased by another 50 cents to sell them for $7, then she would actually be only selling 26 necklaces. So it would be 7 times 26. So you can see that this is going to change depending on how many increments of 50 cents we choose to sell them for. So when we set these up, we've got to factor these things in. Our number of necklaces sold started at 30, and the price they sold for started at 6. So I'm filling in 30 for the number of necklaces sold, and I'm putting in 6 for the price that we're selling them for. I know that if I increase that price, so I'm going to put plus 6 plus, I'm going to increase by groups of 50 cents. I'm going to put my 0.5, but I'm going to times that by x, and x would be the number of 50-cent increases in price. So as I increase my price by 50 cents, for every 50-cent increase, my number of necklaces will decrease by 2. So as if my x was 1, if I increased the price by one group of 50 cents, I would decrease by one group of 2. If I increase 2 groups of 50 cents, so increase to $7, I'm going to decrease by 2 groups of 2. So hopefully this makes sense in terms of revenue. Now her cost, and I should put a let statement to that effect, which I'll add in after the fact, her costs will be the number of necklaces times how much it's costing her to make the next necklace. So number of necklaces times the cost to make each one. Now the cost to make each necklace is $1.50. Make each. The cost to make each necklace is $1.50. Regardless of if she makes 5, it'll be 5 times $1.50. If she makes 30, it'll be 30 times $1.50. If she makes 28, it'll be 28 times $1.50. But since it's going to be dependent on how many we're selling, we're going to put the number of necklaces, which is 30 take away 2x, that has to multiply the $1.50. Okay, and the $1.50 does not decrease or increase by any factors of x. It's just $1.50 no matter how many necklaces we're making. Her profit then is revenue take away cost, and in the end we want to maximize that profit. So we're going to need to come up with our quadratic based on revenue, what we figured out for revenue, subtract the cost, and to maximize we need to look at where that vertex is. All right, so try and work through those 2 problems, and then I'll do a solutions up on my next video.